In this video, we are going to solve numerical problems in degree of freedom. As I given here, degree of freedom comes under Kutzbach criterion and Grubler's criterion as well. And the basic formula for degree of freedom is 3 into n minus 1 minus 2l into h. This is the basic formula for finding out the degree of freedom. General degree of freedom is defined as the ability of a component or a system that can move freely in different directions. There is a basic definition for degree of freedom. Here it is denotes in terms of numerical values as a result. Here I have given over here, if degree of freedom is less than or equal to minus 1, it is said to be a statically indeterminate structure. Because for degree of freedom, for example, if you take this pen, it can move in any direction. It can move in this direction, and up, down, in all the direction it can move. So it has a degree of freedom as 6. It will be moving in all the directions. So this is the degree of freedom. For example, if a degree of freedom is less than minus 1, it is said to be there is no motion for that. So it is said to be a statically indeterminate structure. And then degree of freedom is 0. Degree of freedom is 0 means there is no movement for that material or a component or any system. If there is no movement, it is said to be a statically determinate structure. We can determine it because there is no motion. If you take the pen, if you keep here, for example, if you keep it over here, if there is no movement for this, in any direction there is no movement, then it is said to be a degree of freedom is 0. The material that can move with freedom is 0. So it is a statically determinate structure. We can determine it. And then if we talk about degree of freedom is greater than 1, it can move in any directions, at least one direction. If I keep the pen like this, it moves in one direction. So it is a degree of freedom as 1 in negative x direction or negative y direction or any kind of directions. We have 6 directions, x, y, z, and x dash, y dash, and z dash. So if the maximum the material can or any component can move in 6 type of directions, there is a degree of freedom. So in this concept, we are going to solve problem. 4 problems we are going to solve one by one. We can see. This is the first problem, as you can able to see in the figure. This topic comes under the kinematics and dynamics of machines. We can solve this first problem. First, I already said the basic formula. Degree of freedom is equal to 3 into n minus 1 minus 2 into number of lower pairs and h is a higher pairs. First we have to find out all the unknown terms. This is n, number of links. N is the number of links. So we have to find out the number of links over here. So we can take the fixed links as 1. Always you have to take the fixed link as common as 1. This 3 is considered as 1. This is the first link. And then from here to here is the second link. And then this joint is third one, and this is like a plate like structure. You should not consider this separately. You don't need to put 3 links. It is a plate like structure, so you can consider this a 4. This is a fourth one, and then 5, 6, 7. There are 7 links over here in this diagram, so we can write it as 7. Don't confuse over here. This is a plate like structure, so we should consider this as a plate. This is as a one link, one separate link. So we can take it as 4 as a separate link. So I have written n as 7. Then we have to find out the L, binary joints and ternary joints. We have to find out these things. Here we can easily able to find out over here with the help of the diagram. This is one binary joint. First binary joint. I simply write as a B. Binary joint is a B, and then I have considered this binary joint because here it's a fixed and there is a fixed joint over here. From here to here there is a joint. So we can take it as, consider this as a binary joint. And from these 2 links are connected from in this point. So we can take this as second binary. And then from third to fourth, this is third binary. And then I am writing this as a B is a binary. You can able to understand it. And then from 6 to 4, this is the 6th one, from 4th one, this is a 4th binary. And then from 5th one to 4th one, this is 5th binary. From 5 to 7, this is a 6th binary. And then from 7th one to 1st one, we can take it as 7th binary. And then from here 6 to 1 is a 8th binary. So we can calculate it. This is the first binary, second, third, fourth, fifth, sixth, seventh, eighth. Totally there are 8 binary joins. And then we have to find out the ternary joints. Any ternary joints available in this diagram? There is no ternary joints. Ternary joints means the structure will look like there will be a 3 combination. There will be a 3 links from this point like this. This is a ternary joint. There is no ternary joint like this. You should not tell this like structure is a ternary joint, because this is a plate like structure. You should not consider this. Please keep it in mind. And then we have to find out the L and N, and then we have to find out the H. H is a higher pair. Higher pair is only considered for the rolling systems. For example, if you drive a car, there will be a tire. So this tire to the surface is considered to be a higher pair. Or if we consider any cam, if a cam like structure and any roller, so this particular point is considered as higher pair. Here there is no higher pair like that. So we can consider as 0. Then we can apply all these values in the formula. 3 into n minus 1. n minus 1 is 7 minus 1 minus 2 into h. 2 into L. 2 into L is 8 minus 0. After applying this formula, you can write as 18 minus 16. The answer will be 2. As I already told over here, if the degree of freedom is less than or equal to minus 1, this is statically indeterminate structure. From this numerical we have got greater than 2. We have got 2. So this comes under this degree of freedom greater than or equal to 1. So this is having a constrained motion. So from this we can able to understand that value is 2. We can say that it having a constrained motion. If you are adding 2 motion as input, we can say it as a constrained motion. This is a basic found what you have. This is a basic result what you have found from this numerical. And the next we will move on to this problem. And the basic formula what you have to find: N, L, and H. This is three things we have to find out. We will find one by one. This is the first link. This is first one from this is base. And here you should not go a second one, because the first base itself fixed in a plate like structure. So this is also the first one. This both are same only. This is first one. Why? Because here it is fixed. This is a plate like structure. If the fixed position is attached to the plate like structure, we should consider this plate also as 1. And then next this is second one. I am writing the links. Third one, then 4, 5, 6, 7, 8. I have written all the things. Okay, there are 8 links. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 links over here. So we can write n equal to 8. And then we will find out the number of binary joins. For finding out the binary joins, it will be easy for you. From 2 to 1, there is a 1 binary joins. And then from 3 to 1 binary. Then 8 to 1 binary. There are 3 binary. And then from here, it is a ternary, because one here link is there, another link is there. Here is a platelet structure. It is also considered to be a 1 link, third link. So here there are 3. As I already told, here if the 3 links are there, it is said to be a ternary. So here in this diagram, we can see it as ternary. This is one ternary. And here the same symmetrical structure. This is 1 link, another link, another link. This is a ternary, second ternary. And then the next binary, here 1 binary, here 1 binary, here 7 to 8 1 binary, here 6 to 8 1 binary, as I already written over here, and here 1 binary, this point, here also 1 point. We can count the number of binary over here: 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. There are 7 binary. 7 binary plus 2 ternary. 2 ternary means we have to write it as 2. 1 ternary, here 1 ternary, here 1 ternary. So we have to multiply with 2. There are 2 ternary, we have to multiply with 2. This is a basic formula for ternary. And then the total value is 11. So you can able to write over here. The number of higher pairs is 0, because there is no any roller friction. So we can put it in the formula. degree of freedom is equal to 3 into n minus 1 minus 2 L. 3 into n minus 1 is 8 minus 1 minus 2 into L is 11. You can write it as 21 minus 22. It is said to be a minus 1. This is the value of the degree of freedom. We can say it as statically indeterminate structure. These are the two problems using a degree of for finding out the degree of freedom with the help of the Kurzbach criterion. I hope this video is useful for you. For more information, please subscribe this channel. Thank you.